Okay, so welcome to my YouTube channel. We're going to look at organic chemistry part 4. Organic chemistry part 4. So in the recent videos we learned about the homologous series, alkanes, alkenes, all those things. Now we are now on the third homologous series. We have talked about two homologous series, alkanes and alkenes. Now I want to look at the third homologous series, which are called the alcohols. So before I get into details, if it's your first time to watch my videos, please subscribe to my YouTube channel. I would appreciate, and you can leave a comment on how can I improve on my lesson, recommendation, as well as any video you want me to make, like to shoot on a topic. Okay. So alcohols. What are alcohols? Alcohols, these are organic compounds which are made up of the elements hydrogen, carbon, and oxygen. Alcohols, these are organic compounds made up of the elements hydrogen, carbon, and oxygen. Therefore, these are not hydrocarbons. We say the hydrocarbons, they only contain these two elements, hydrogen and carbon. Now for alcohol, they also have the element oxygen. So alcohols are organic compound which contains the element hydrogen, carbon, and oxygen. Now they have the general formula. Alcohols have the general formula of CN H2N plus 1 OH. The general formula for alcohols is CN H2N plus 1 OH. Now, okay, like that. So that's the general formula. Therefore, all alcohols, they have the functional group of OH. All alcohols have the functional group of OH, which is called the hydroxyl group. Now, when you hear the hydroxyl group, you may think of the bases. This hydroxyl group, which is found in alcohol, does not dissolve or does not ionize when dissolved in water. Therefore, the alcohol is neutral to litmus and other acid-base indicators. So the alcohol is neutral. It is not a base, because this hydroxyl group, which is found in the alcohol, is not or does not ionize when dissolved in water. So it's not a base, it is neutral. Okay, so all alcohols, they have an hydroxyl group as a functional group. The formula for hydroxyl group is the OH. Okay, that is the functional group. Now we want to look at the first 5 alcohol. The first 5 alcohol. Now bear in mind that alcohols are also called alkanols. Alcohols are also called alkanols. So now we want to list the first 5 alcohols. We want to list the first 5 alcohols. So we'll be writing the name, then also the molecular formula and the structural formula as you have been doing it. So here is the name of an alcohol. Here is the molecular formula. Then here is the structural formula. Okay, so the first alcohol has 1 carbon. So if you want to know each molecular formula. Okay, first that is called the methanol. That is called the methanol. So the names of alcohols are similar to the names of other, the one we have discussed about the alkane and the alkenes. Meth means one. Now, from the word the alkane, or should I say methanol, in this case, from the word the methanol, methane, they have just removed an E and you put the OH. They just remove the E and you put the OH to make it an alcohol, methanol. That's why these are called the, remember I said they are called the alkanols. They're called alkanols. From the word alkane, they've removed this E and they put the OL to make it an alkano, as an alcohol. So even here, we'll just be removing the E from the names of alkanes and put the letters OL. Okay, so methanol. Methanol has one carbon. Meth means one. So to know the molecular formula of a methanol, if you are not sure, you use the general formula. You use the general formula where we say CN H2N plus 1, then OH. So where there is N, you put 1, so C1 H2 times 1 plus 1 OH. So the 1 you don't show it, then H2 times 1 is 2 plus 1, that is 3, then OH. So this is the molecular formula for methanol. That is the molecular formula for methanol, which is CH3OH. The structure formula is C, then you remember carbon must form 4 bonds. The 3 hydrogens are here, then the other one is a functional group, which is the OH. If you can put the bond there again. Okay. Now, in this case, as I said earlier on, the OH is the functional group for these alcohols. The OH is a functional group for these alcohols. So the second, alcohol is called ethanol. So ethanol, the molecular formula for ethanol is C2H5, then OH. If you are not sure, use the molecular formula, the general formula, which is CnH2n plus 1 OH. Where there is N, you'll be putting the 2, so you have C2H. There is 2, so 2 times 2, that's 4 plus 1, that's 5, then the OH, like that. So draw the 2 carbons. Okay, so we have hydrogen there, we have a bond there. Then this one, it has 2 hydrogens, and the other one is the OH. So that is the structure formula for ethanol. Then we look at the alkanol with 3 carbons, or an alkane. So an alkane with 3 carbons is called the propanol. It's called the propanol. Propanol is just adding the CH2. Remember the difference between the two. So C3H, so plus 2, that becomes 7, then OH, that is the propanol. So you draw this structure formula, C, then we have bonds all over. I'm not saying that always the OH will be there. No, OH can be here, can be there, can Okay, so I'm not saying the OH is always there. Now, that is the structure formula for propanol. You don't forget that the functional group for alcohols, the OH, the functional group is the active part where the chemical reaction takes place. The functional group is a part of an alcohol or of an organic compound where the reaction seems to take place. Okay, you can continue listing them and finishing and drawing and highlighting the molecular formula as well as drawing the structural formula. So this is how we draw the molecular formula and the structural formula. Okay. Now, what about the isomers of alcohols? Isomers of alcohols, isomerism. Remember, we defined an isomers as the organic compound with the same molecular formula but different structural formula. Organic compound with the same molecular formula but different structural formula. So isomers of alcohol. Isomers of alcohol. Isomers of alcohol. So we want to do the isomerism. Now, when looking at isomerism of alcohols, it also involves the change of position of an alcohol. So we start with the propanol. I want to start with propanol. So propanol of which the structure of propanol is C, the molecular formula is 3, then H, then we have 7, then OH. So to draw the structure formula of propanol, we want to know which one is the isomers of propanol. The 3 carbons, so 3 carbons, 1, 2, 3. Okay. Then we have the alcohol there. Hydrogen, 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 hydrogen there. Okay, that's propanol. Now another structure is this. So the alcohol is no longer there. Alcohol is now here. Okay. Now you need to be careful when you write it here. You need to be careful. Okay, you need to be careful here. The oxygen is the one which is supposed to bond with the carbon, not hydrogen. So if your arrow shows that, becomes wrong, because this will indicate that hydrogen is forming 2 bonds, which is wrong. Okay. So what are the names of these 2 alcohols according to UPAC? There is what is called UPAC, which you are going to learn most of it in the higher levels. UPAC, we're talking about the International Union of Pure and Applied Chemistry. Okay. Now we want to give the names of these according to UPAC. So the name of this is, you identify the location of the alcohol group. Now, when naming of organic compounds, alcohols, the group alcohol is always given the first priority. So identify the group of an alcohol, which is the hydroxyl. So that's an hydroxyl. Then it is at position 1. They should always be given the smallest number as possible, just like what we've been doing all along. So 1, 2, and 3. So the alcohol group is there. So when you identify the alcohol group, you need to know the mother chain, of course, the mother chain, the one with the longest carbon chain. So here we just have one chain with 1, 2, 3 carbons. So here the mother chain is propanol. The mother chain is propanol, or should I use the word propane first? Now, because it's an alcohol, we are going to drop the E and put OL, which becomes the propanol, like that. So that's the mother chain. Now, at which carbon is the alcohol or the functional group? So the alcohol or the functional group is at carbon 1. So this becomes the 1-propanol. So the name of this is 1-propanol. The name of that is 1-propanol. See that then? That's the name of that. Okay. And if you have questions on that, you can leave the questions in the comment section below. Then for this one, it's the same propanol, but the structures are different. This time, the alcohol is at carbon 2. So 1, 2, 3. This becomes the 2-propanol because the functional group of the hydroxyl is at carbon 2. So that's how we deal with the nomenclature of the isomers of alcohols. Now, apart from isomerism of alcohols, you need to know the reaction of alcohols. Or maybe we do another example of isomers of these. We go to the one with the 5 carbons. We go to pentanol. So we have CN H2N plus 1 OH. So pentanol, why there is then we put the 5, so C5, then there again is a 5. So H 2 times 5, that's 10, plus 1, that's 11, then OH, that's pentanol. So with the pentanol, we want to draw the isomers. So we have different a number of isomers of pentanol, which one of them would be the C. That's supposed to be 5. Okay. Okay, so it would be like that. Okay, that's one of the pentanol. The next one, 1, 2, 3, 4, 5. Okay, so we may have here. Okay, so that's also pentanol. We may have this. That's 4. We have the other carbon here, which is that. Then we have the alcohol here. Okay, plus many more. The many have just used these 3. So this one, as you might have guessed, is your 1-pentanol because the hydroxyl group is at carbon 1, so that is 1-pentanol. That's 1-pentanol. Then this one, it is you identify the position of the group. So when counting, first check which side can you count to give that one the smallest number as possible. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. So either you count from this side or from that side. The hydroxyl is still, at carbon 3. So you can start from each side, whichever side you pick, you want to start with. So the position of the alcohol is at carbon 2, and the name of the longest is pentanol. So 2-pentanol. So that is 2-pentanol. that is 2-pentanol. The group is at 3-pentanol, sorry, it's 3-pentanol because the hydroxyl is at carbon 3. Now this one, it might seem a bit different, but we did this in the previous videos. It's just a contribution or continuation. So this is a branched alcohol which has a branch. So whenever you have a branch, you need to identify the longest chain between those branches. So if you check this branch, we only have 2 carbon, 1, 2. If you check this branch, we have 1, 2, 3, 4. We have 4 carbon. So the longest chain becomes the parent name. So what name is given to an alcohol with the 4 carbons? It's called the butanol. It's called the butanol. At which position is the hydroxyl group? So if you count from this side to get carbon 3, if you count from this side to get carbon 2, so you better count from this side 1, 2, 3, 4. So that the group is at carbon 2. So this is 2-butanol. Okay. Then you need to identify the group which has been attached to the mother chain, which is, if you remember, we said this is a methyl in the previous videos. So that's a methyl. And at which location is a methyl? At carbon 3. So that is a 3-methyl. Okay. So now to complete the name, it becomes a 3-methyl. 3-methyl. Write it here. Becomes a 3-methyl. 3-methyl. Then you write the parent name, 2-butanol. 2-butanol. Okay. If not that, like we did with alkenes, it can also be called the 3-methyl. 3-methyl. Then you write but. Then you hyphen. Then you write the 1. Okay, it's a 2. Then like the whole L, like that. Just like that. Okay, I've forgotten the N there. So you can either use this method or use that method when naming the alcohols, but this one is easier for everyone. Okay, so those are the isomers of the alcohol. Now, when you know the isomers, you have to know that these alcohols does not naturally occur in the crude oil. We're going to do a video in crude oil. So the alcohols are not naturally occurring in the crude oil like the alkanes and alkenes. So these are just made. So alcohols are made from, there are made 2 major methods of making alcohols. One, hydration of alkenes. In the previous video we talked about hydration of alkenes. So alcohols are made from making of alcohols. Yes, making of alcohols. So one, alcohols are made from hydration of alkenes. Hydration of alkenes. Apart from that, fermentation of carbohydrates. Fermentation of carbohydrates. Fermentation of carbohydrates. So the alcohols can be made by these 2 major methods. We have hydration of alkenes and fermentation of carbohydrates. Okay. Now, in hydration of alkenes, we said this is the addition of water molecule to an alkene. The addition of the water molecule to an alkene. So, for example, we can give ethene. So where we have ethene plus water, we're going to have ethanol. Ethene plus water, we're going to have ethanol. Okay, now we can show this in the structure formula where I have ethene. Okay, yeah, that is ethene. So this ethene, we're going to add it with water, which we're going to have, we said the bond will be broken open. Remember, the bond is broken open like that, and it allows the accumulation of these atoms or molecule of water. So the other hydrogen will bond to the other side, then the remaining OH, bond itself to the other side, which will form a compound. See, so we have the OH there, hydrogen, 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 and the hydrogen from the water molecule. This becomes ethanol. So alcohols are prepared by the method called hydration of alkenes. Now, the second method of preparation of alcohol, especially ethanol itself, is fermentation of carbohydrates in the presence of an enzyme called the Isomers. So fermentation of carbohydrates in the presence of an enzyme called the Isomers. So fermentation So in talking about fermentation of carbohydrates, for example, glucose has a formula C6H12O6 in the presence of Isomers enzyme. In the presence of Isomers enzyme, it's going to produce ethanol, which is the C2H5, then OH plus the carbon dioxide as a gas. Okay. This is fermentation. This one is the one which is used in what carbon dioxide there. It's the one which is used by industries to produce most of the alcohols which people consume, because alcohol, specifically ethanol, is the one which is mostly found in most of beers. Okay, so this is an industrial preparation of alcohol. So when they're asking questions, sometimes they can specify to say, write the equation for the industrial preparation of alcohol. This is the industrial method which they use to make alcohol in large quantities. Okay, so this is the fermentation of carbohydrates to form an alcohol, specifically ethanol. Okay, now apart from this process of fermentation, apart from the process of making alcohol, you must know as well the reactions of alcohols. You must know as well the reactions of alcohol. So, reactions of alcohols. Reactions of alcohols. So what are the reactions of alcohols? One of them is oxidation. So look at oxidation. Look at oxidation. Oxidation, this is the process where an alcohol reacts with oxygen in the presence of concentrated sulfuric acid. So we are talking about addition of oxygen here. So if this is an alcohol, for example, we use the same ethanol. So where we have ethanol, I'll use the structure formula. ethanol plus oxygen. Now in this case, it's not really as in reacting, but it's being oxidized. So it's not really like the reaction is taking place between oxygen and that, but it's just an oxidation anyway, the addition of oxygen. So we have the O2 there. It's going to produce him. Now, what are the products when an alcohol reacts with the oxygen? What are the products when an alcohol reacts with oxygen? So the product will be a carboxylic acid and water. The product will be carboxylic acid and water. So what happens is, one atom of oxygen in this oxygen molecule. So we have oxygen, oxygen. One atom of this oxygen molecule will react with one hydrogen atom from the compound to produce water. And this oxygen will bond itself to carbon there. Okay, that's what will happen there. So this will be C. Okay, now the oxygen has the ability to form two bonds because it has a valence number of 2. So this will be oxygen, we have 2 there. Then we have now the hydroxyl group. Then we have the remaining hydrogen now. Then it plus water that side. So plus the H2O at the end. So this is the carboxylic acid which is formed during the process of reaction. So one oxygen atom will substitute, should I say substitute? It's going to substitute this hydrogen from each compound, then to produce water there. Okay. Then when it goes there, we are going to have water plus then the same alcohol which has been formed, and then carboxylic acid. So the name of the acid depends with the name of an alcohol which has been oxidized. So this is ethanol. The name of this acid will be ethanoic acid. Okay. When looking at carboxylic acid, you are going to learn that is its functional group. Okay. And next of questions. Apart from oxidation, we also have different other type of chemical reaction like combustion reaction. Remember, I said all organic compounds they undergo combustion reaction. Now, the combustion reaction is the burning of fuel. In this case, the burning of an alcohol with oxygen to produce carbon dioxide and water. Okay. Apart from combustion, we have what is called the dehydration, the removal of water. So we have dehydration. Dehydration is the removal of water from an alcohol. In this case, dehydration is the removal of water from an alcohol. So when you remove water from an alcohol, for example this one, then excuse me, ethanol. You remove water from ethanol. Remove water from ethanol. This is the water part. You see that, right? The H2O. So if you remove these two parts, you are going to produce what is called an alkene. Going to produce an alkene with a double bond. Remember we said alkenes have double bonds. So dehydration produces an alkene plus water which has been removed. So that is dehydration of alcohols. And apart from that, we have esterification. Okay, we have esterification. Esterification is the process of making esters. So this takes place between the reaction of carboxylic acid and the alcohol. So alcohol undergoes what is called the esterification reaction. alcohols undergoes the reaction called the esterification. So apart from these reactions from discussing, the fourth one is called the esterification reaction. So this reaction esterification is the process of making esters. So when you say esterification, we'll be reacting an alcohol plus an acid, which is a carboxylic acid, then you are going to produce an ester. Okay, so for example, if we use ethanol, okay, ethanol plus maybe we use the same ethanoic acid. So to explain it better, I'm going to do this. Remember, ethanoic acid has that kind of a bond. Then you have hydrogen is there, also have hydrogen that side. So esterification is the reaction between an alcohol and the carboxylic acid. So what happens is this: the hydroxyl part of the ester combines with the hydrogen from the hydroxyl of the alcohol to produce water. Hear that, eh? So this will combine this one and this one. Then it will allow this atom to come and combine with this oxygen, which will form the structure. We have C, the first part, and now we have this oxygen, which will bond with this carbon, which has just lost the hydroxyl. Okay, this carbon there. Then the same carbon, remember, it has a double bond with oxygen. Okay, then we have another carbon that side with the 3 hydrogen. Okay, so that is the structure. Okay, this one is okay. So that is what is called esterification. Esterification is a process where an alcohol reacts with a carboxylic acid to produce an ester. So the name of these esters, again, it depends on the alcohol used and the carboxylic acid. But the first part of the ester is the name of an alcohol, then the second part is the name of an acid. So this is called ethyl ethanoate. From ethyl from ethanol, and ethanoate from ethanoic acid. So this is ethyl ethanoate. We're going to look at this as we'll be looking at their homologous series, or their group specifically. So these are some of the reactions which alcohol undergone through. What do you think are some of the uses of alcohol? Alcohols are used as fuels. Apart from that, alcohols are used to make methylated spirits. Alcohols are also used in food beverages, and many other uses of alcohols. And also sterilization of utensils like methylated spirit. Using sterilization of utensils like in the hospitals to clean the equipment being used in hospitals. So that is all for today. That is organic part 4. Then watch out for the next organic part 5, where we'll be looking at carboxylic acid. So thank you for watching. Don't forget to subscribe, hit that like button, and share, as well as like the video for more videos which will be coming for you. Thank you.